Hello and a very good morning to everyone. My name is Kumar Alakusundram. My matrix number is B0717109181 and I'm from 4BMMV. I would like to thank to my supervisor and my panels, which is Muhammad Afiq Amiruddin bin Pau known as my supervisor, and my panels Muhammad Saiful Fidaus bin Hussein and Puan Izzatul Farain binti Azmi. Thanks for giving this wonderful opportunity to present about my IoT-based arm robot. Since the time given to me is little, well, I'm going to recap some part from Chapter 1, Chapter 2, and Chapter 3, the introduction, literature review, and the methodology. And for Chapter 4 and Chapter 5, I'll go into details. This is the IoT-based arm robot. That's a simple poster of this. Okay. For the introduction, basically, IoT is a system of interrelated computing device, mechanical and digital machines that has the ability to transmit data without the need of humans' interaction. The usage of this technology can be easily seen all over the world. For example, smart homes. People are able to control lights and electronic devices by voice command or our smartphones. Next example would be the security system, where we're able to be alerted through our smartphones if the alarm goes off. So thinking on a rough idea on what IoT and brings us to the project, which is an IoT-based robotic arm. We intend to use this robotic arm that is controlling using an application on our smartphones. Through the usage of this application, we will be able to command the arm to turn left or right, to extend the arm, or to retract the arm. So coming to chapter 2, where it is the literature review, I'd like to brief some of it. In our current era, we live in a world where technology is becoming more advanced every other minute, and the world has a lot to offer, such as the Internet of Things. There are many ways IoT comes in handy, and in this case, we can see how IoT is applied on a robotic arm. In this chapter, we will look at some content from articles, discussion, and researches that has relevancy with the IoT robotic arm. The article will explain the development and the function of the IoT robotic arm that is remotely controlled using a mobile application. According to some articles and research, the writer explains on the development of the device as well as the features and the background information on the project and the system. Through the articles and researches, we understand the concept of robotic arm, which will be explained in the next slide. This setup of robotic arm is explained along with the description and very detailed information. Out of three articles that I learned, the first article that explains how the writer was able to build an IoT-based robotic arm using servo motors and NodeMCU board. In this article, all sorts of different and useful information is provided, such as the schematic, circuit connection, the required components. He also explains about how the features and the function of the system as well, and also not forgetting what the writer explains how the information is transferred by the instruction that is given from the mobile device using the Blynk application, right up to the movement of the robotic arm that is controlled by the four servo motors. Well, for the next article, similar to the previous article, which is the International Research Journal of Engineering Technology, also had a write-up on how an IoT-based robotic arm, but this project is different from the previous one because the article speaks about how the robotic arm is linked to a microcontroller, Freescale Freedom KL2G5Z board and a Wi-Fi module instead of the NodeMCU. The writer of this article also shares the beneficial of uses of IoT technology and how it plays a major role in the development of our future. This is proven via project developing an IoT-based robotic arm. The, the third article would be the writer had conducted a project where he developed an IoT-based robotic arm, but GPIO used as Raspberry, which is general purpose input and output, instead of using mobile application. The writer uses a web page to provide the instruction on the movement of the robotic arm. The writer provides information on the development of the Raspberry Pi controller, diagrams for better understanding as well as the development of the web page and etc. Coming to chapter 3, which is methodology. To accomplish the complete development of the IoT based robotic arm, there must be a proper management of the development stages. Preparation of all the necessary hardware and software that are required for this project. Moreover, the process of linking all the hardware and ensuring the functionality of the overall product is as desired plays another major role. The process of testing and checking comes into play here. The diagram above displays the steps involved in the preparation stage of this project. First off is gathering all the necessary hardware and software and assembling the entire system. Then, we are to check on the compatibility of the system. Here we need to see if the hardware can link properly with the software. Otherwise, we need to trace back what went wrong and how to see we can make the necessary amendments. Next, two things to be called about definitely about the hardware and the software. The system is a combination of hardware and software and both plays a major role in running the system. If one of them have to any issues, then there could be a possible the entire system will fail to work. Well, looking at the first hardware, which is the main hardware for this project, which is the NodeMCU. It is actually an open source IoT platform where input and output components can be linked to the board. IoT features means it can receive wireless transmission, for example, from a mobile application using a Blynk that communicates with the NodeMCU through a wireless connection. Next would be the servo motor. Basically, a servo motor behaves as a component that can either push or rotate an object with great precision. The servo motor has three connections where the orange wire is for the PWM connection and the black wire is the ground connection, and lastly the red cable is the connection for the voltage input with a rating of 5 volts. Last hardware would be the robotic arm. It's a type of mechanical arm where the arm is quite similar to the human arm. Basically, the robotic arm was invented to be used in factories and working environments that require high efficiency. For the software, which consists two Arduino IDE and Blynk, sorry. The Arduino IDE is actually a C++ compiler that includes all the Arduino libraries. This IDE is normally used to return Arduino code sample, which is later then uploaded into the Arduino microcontroller board. In our project, we will be using this Arduino IDE to write the code for the NodeMCU. So, the result and discussion will describe briefly about the result and analysis of project development of the 6 degrees of freedom robotic arm. The project system development consists of hardware and software, which the result will be explained in detail. Moreover, the project had been assembled and tested to know the functionality and the accuracy of the system. Furthermore, the project data analysis and discussion of the system had accomplished which had been clarified in objective of the project. So this would be the establishment of the Node MCU Wi-Fi connection. First of all, the initial setup was to link the Node MCU to a computer that has an Arduino IDE as because Node MCU can be programmed using the Arduino language. Upon doing so, it was necessary to identify the SSID and password of the wireless internet connection that was to be used to connect the internet similarly to how computers and smartphones do. This is generally the token that is generated when the creating a project on a Blynk application, so the NodeMCU, which is called ESP8266, will only communicate with that specific project. If the internet connection is active, then the NodeMCU will be connected to the internet and Blynk always. Next would be the setting up the Blynk application. The device was NodeMCU while the connection type was Wi-Fi. The figure below shows the information request screen. Upon clicking on the create button, a notification indicating that an authentication token was sent to the logged in email address. This code needs to be taken and keyed into the NodeMCU script. Since the robotic arm is 6 degrees of freedom, therefore there was a need of having total of 8 buttons where each button will control the following movements, as you can see in the figure next to it. Well, this is Blink application development. This is how Blynk application looks like after setup is done. Generally, when the user clicks on a button, the information will be transmitted to the Blynk server, where the server will then transmit it to the MCU to indicate the movement of the robotic arm. The button is also said to be used the push function. This is generally means that the signals are high only if the button is pushed, otherwise it is low. Next would be the Arduino IDE code. Arduino IDE has been applied to build the code. Start with the placing the library and declare the library as figure. As you can see in the diagram I showed. Coming to the prototype project development. It is extremely important that all the features and parts are added in these prototypes. Prototypes are sometimes used for testing and presentation purpose as well. All the parts and equipment were then gathered and tested using some general codes to ensure they work correctly and is functional. The robotic arm is then linked to the NodeMCU, and also the push buttons, which act as a manual controller, are integrated with the NodeMCU as well. Upon doing this, the hardware is completed where the hardware connection is seen below. Lastly, the Blynk controller unit was then set up and all the necessary commands and settings were edited in the application. As you can see, this is the prototype development where it starts from zero until the end, which is from initial from the taking parts and placing it on one place, which is controlled by all it by a smartphone. Coming to the end, conclusion and the recommendation. I would like to conclude that we say that the 6 degrees of freedoms a useful product that assists humans in many ways. The technology can help in making humans easy to expose to danger where humans don't need to work directly in the manufacturing but work in a safer location where they control the robots using a controller unit. Well, the next is I would like to recommend the improvement is using a robotic arm that is made of stronger material. As seen in the project, a robotic arm that was used in the made low cost material compared to the industrial robotic arms that are made of strong structure material. The prototype is prone to damage when under high stress from heavy loads such as the structure deforming. Therefore, it is noted that better material with greater thickness can be used to improve the durability of the robotic arm. Lastly, I would like to recommend the future project enhancement if the robotic arm have to work simultaneously also can by adding sensor and upload the new codes in the Arduino IDE script where we can control through the mobile application if some problem occurred. Otherwise, it can be done automatically under the sensors. Thank you. I hope this audio will be clearly listened to all of the panels and my supervisor. If some lacking happens, I'm so sorry for the inconvenient trouble happens during this presentation.